Question is, if f and g are continuous functions, satisfying f of x is equal to f of a minus x, of a minus x, and g of x plus g of a minus x is equals to 2. Then show that integration of 0 to a f of x into g of x, f of x into g of x is equal to, or dx is equals to integration of 0 to a f of x dx. This is the question. Let I is equals to integration of 0 to a f of x into g of x dx. So we know that this result, integration of 0 to a f of x dx is equals to integration of 0 to a f of a minus x dx. So now if you use this result, then what you get, this I is equals to integration of 0 to a, replace x with a minus x, that is f of a minus x into g of a minus x dx. This is the first. Next, what you do is, from the first condition, that is f of x is equal to, from this condition, f of x equal to f of a minus x, or f of a minus x equal to f of x. So integration of 0 to a, replace f of a minus x with f of x. Now from the second condition, from this condition, g of a minus x equal to what? 2 minus g of x. 2 minus g of x dx. So this is equals to integration of 0 to a, if you open the bracket, 2 times integration of 0 to a f of x dx minus integration of 0 to a f of x into g of x dx. This is I. But what about this one? This is again I only. I is equal to integration of 0 to a f of x dx. So if you replace this, I is equals to 2 times integration of 0 to a f of x dx. If you replace this with I, minus I. So you take out minus I this side. Therefore 2I is equals to 2 times integration of 0 to a f of x dx. So 2 to cancel. Therefore I is equals to integration of 0 to a f of x dx. So we have taken I is equal, so this, let this be 1. We have taken I is equal to integration of 0 to a f of x dx. Now we have shown that I is equal to integration of 0 to a f of x dx. Therefore from 1 comma 2, integration of 0 to a f of x into g of x dx is equal to integration of 0 to a f of x dx. So this is the proof. So next one is, this is the solution. Next question is, evaluate integration of 0 to pi x over 1 plus sine square x dx. So this is the question. So solution. So let I is equals to integration of 0 to pi x over 1 plus sine square x dx. Now again here also use this result, integration of 0 to a f of x dx is equals to integration of 0 to a f of a minus x dx. So use this result. So with this result, so what happens, this I will be equal to integration of 0 to pi, replace x with pi minus x. Pi minus x over 1 plus sine square pi minus x dx. So this is equals to integration of 0 to pi. So this is pi minus x over 1 plus sine pi minus x is whole square is sine square x only dx. So if you separate it, integration of this pi into integration of 0 to pi, 1 over 1 plus sine, otherwise, okay, 1 plus sine square x dx minus integration of 0 to pi x over 1 plus sine square x dx. Again, this is equals to I only. Therefore, this one, therefore, integration of 0 to pi x over 1 plus sine square x is nothing but this I only. So I is equals to this I is equals to pi into integration of 0 to pi 1 over 1 plus sine square x dx minus I. So take out this minus I left hand side, then 2I is equals to pi into integration of 0 to pi 1 over 1 plus sine square x dx. So now this I is equals to, therefore I is equals to pi by 2 into integration of 0 to pi 1 over 1 plus sine square x dx. So to solve this integral, you can you write that sine square x is equal to 1 over cosine square x. Therefore 0 to pi, this is equals to, if you write sine square x equal to 1 over cosine square x, therefore this integral becomes cosine square x over cosine square x plus 1 dx. So now this cosine square x is equal to cosine square x minus cot square x equals to 1. Therefore, cosecant square x is equals to 1 plus cot square x. So if you replace in denominator, in place of cosecant square x, 1 plus cot square x, then what you get, pi by 2 times integration of 0 to pi cosecant square x dx over 1 plus cot square x. Therefore, cot square x plus 1, already 1 is there, plus 2. So why I converted in denominator cosecant square x in terms of cot square x? Because if you consider this as t, you can make the substitution t equal to cot x. If you make this substitution t equal to cot x, therefore differentiation of cot x is minus cosecant square x. So this is the part of the integrand. The differentiation of cot x is the part of the integrand, the two that is with dx. So now what I do is, let t is equals to cot x. If you make this substitution, then dt is equal to minus cosecant square x dx. That implies cosecant square x dx equal to minus dt. So replace this cosecant square x dx in denominator with minus dt, and we should change the limits also. So lower limit, here we will find the limits extending to here 0 plus. If you approach 0 from right hand side, then t tends to, that is cot x tends to infinity. This is the lower. Now upper limit, here upper limit is also extends to pi, then cot x tends to, that is t tends to minus infinity. So now the limits are, therefore I is equal to, now with this substitution, what you get, this is equals to pi by 2 times integration of, here lower limit is plus infinity, upper limit is minus infinity, numerator cosecant square dx is equal to what? Minus dt over this is equals to t square plus 2 can be written as root 2 square. Now this is equals to minus pi by 2 into integration of infinity to minus infinity dt over t square plus root 2 square. So now this is equals to here minus sorry up yes. So if you remove the minus sign, then what you get? Pi by 2 times integration of minus infinity to plus infinity dt over t square plus root 2 square. So now it's an even function. So limits are from minus infinity to plus infinity. So this can be written as pi by 2 times, therefore 2 times integration of 0 to infinity dt over t square plus root 2 square, because integration of minus a to a f of x dx is equals to 2 times integration of 0 to a f of x dx if f of x is even function. So now this 2 cancel. So this is equals to pi into now integration of 1 by x square plus a square is equal to what? Tan inverse x by a. Therefore this is tan inverse x by a t by root 2. The limits are from 0 to infinity. So this is equals to pi into this if you substitute upper limit, that is tan inverse of infinity. Tan inverse of infinity is equals to what? Pi by 2 minus of, okay, we forgot one thing. I think integration of 1 by x square plus a square is 1 by a into tan inverse x by a. 1 by a is 1 by root 2, this one. So integration of 1 by x square plus a square dx is equals to 1 by a into tan inverse x by a. This is the formula. So here 1 by a is what? Root 2. So here pi by root 2, tan inverse infinity is pi by 2 minus tan inverse 0 is 0. Therefore eventually what you get? The answer is pi square by 2 root 2. So this is the answer. Question: evaluate integration of 0 to pi x dx over 1 plus cos alpha into sin x, where 0 is less than alpha is less than pi. 0 is less than alpha is less than pi. Solution: so again, to solve this question, use this result. Integration of 0 to a f of x dx is equals to integration of 0 to a f of a minus x dx. So if you use this result, then I is equals to given integration of 0 to pi x dx over 1 plus cos alpha sin x is equals to integration of 0 to pi. Here this is pi minus x dx over 1 plus cos alpha into sin of pi minus x. Your integral variable is x. So now what you do is, if you open this bracket, that is if you separate this integral into two integral, that is pi dx, one is pi dx over 1 plus sin of 180 minus theta, that is sin theta only. Therefore this is cos alpha into sin x minus integration of 0 to pi here x dx over 1 plus cos alpha into sin x. So this is I. So now again, this one is what? I only. So now this is equals to, this is pi into integration of 0 to pi dx over here alpha 1 plus cos alpha into sin x minus I is equals to I. So from this one, 2I is equals to pi into integration of 0 to pi dx over 1 plus cos alpha sin x. 1 plus cos alpha sin x. Now what you do is solve this question. Here sin x is there. So here, so here sin x is equals to, we have this result, sin x is equals to 2 tan x by 2 or 1 plus tan square x by 2. So therefore 2I is equals to pi into integration of 0 to pi dx over 1 plus cos alpha into, I will replace this sin x with 2 tan x by 2 or 1 plus tan square x by 2. So next what I do is, so you take out this 1 plus tan square x by 2 into numerator, then this is equals to pi into integration of 0 to pi 1 plus tan square x by 2. That is, you can write that as secant square x by 2. Secant square x by 2 dx or here 1 plus tan square x by 2 plus 2 times cos alpha into tan x by 2. Next, why I have written this sin x into 2 tan x by 2 1 plus tan square x, because 1 plus tan square x by 2 is secant square x by 2. If you make the substitution as t is equal to tan x by 2, differentiation is the part of the integrand, that with dx, that is secant square x by 2. So now if you make the substitution t equal to tan x by 2, now let t is equals to tan x by 2. If t is equal to tan x by 2, dt is equals to secant square x by 2 into 1 by 2 from chain rule. We are substituting t equal to tan x by 2. If we change the limits, therefore lower limit will be t is equal to, at x equal to 0, t equal to 0, tan 0 is 0. Upper limit t is equal to pi. T tends to pi, then this tan x by 2 tends to infinity. Therefore t here tends to infinity. Therefore this is equals to pi into integration of, that is 2I is equal to 2I is equal to pi into lower limit is 0, upper limit is infinity. Square x by 2 is equals to what? 2 times dt. 2 dt is equals to secant square here dx, secant square x by 2 dx. So replace secant square x by 2 dx with 2 dt. Therefore 2 dt over tan x by 2 with t. Therefore 1 plus t square plus 2t cos alpha. 2t cos alpha. So this 2 to cancel. Therefore I is equals to pi integration of 0 to infinity dt over this is t square plus 1 plus 2t cos alpha. So next what we do is, so here this is your t square plus 2t cos alpha. So you can write this 1 as sine square alpha plus cos square alpha. So I is equal to pi into integration of 0 to infinity dt, or you rearrange the terms, you write down t square 2 into t into cos alpha plus write down this 1 as cos square alpha plus sin square alpha. So now if you observe this part, so this part is a perfect square. That is pi into integration of 0 to infinity. This is dt over this part is equal to t plus cos alpha whole square plus sin square alpha. Sin square alpha. Now here this t plus cos alpha whole square is variable because integral variable is dt. Therefore, sin square alpha is constant. Therefore, now this integral is of the form integration of 1 by variable square plus constant x square plus a square form. This is equals to 1 by a into again tan inverse x by a. If you use this result, then what you get, this I is equals to integration of 0 to infinity dt over, sorry, use integration, if you use this result, integration of 1 by x square plus 1 by a into, a is what here, sin alpha, 1 by a into, that is pi by a, already pi is there, into 1 by a into tan inverse x by a. X is here, variable is t plus cos alpha, by constant is sin alpha. So limits are from 0 to infinity. So I is equals to pi over sin alpha into tan inverse. If you substitute upper limit, that is tan inverse infinity. I will write directly. Tan inverse infinity is pi by 2 minus. If you substitute lower limit, then what you get, minus tan inverse t is 0. Therefore, cos alpha by sin alpha, that is cot alpha. Replace this t with 0. Therefore, cos alpha by sin alpha, that is cot alpha. Now this is equals to, I is equals to pi over sin alpha into, this is pi by 2 minus. So this is tan inverse. This cot alpha can be written as tan of pi by 2 minus alpha. So therefore, I is equals to pi over sin alpha into pi by 2 minus alpha. So which is equals to, I is equals to pi by sin alpha into pi by 2 cancel alpha. So finally answer is I is equals to pi alpha over sin. So this is the final answer.